Hello everyone. So in this video I will show you the new features for the faults extraction in Seisnetics 602. So after the horizon extraction that you can display of course on the seismic, the idea is you can ask Seisnetics to compute the fault polygons that will be basically the breaks in the horizons on the seismic. So it's really using the discontinuities in the horizons or the geopopulations that have been extracted during the first step. So if I click on any of the surfaces, for instance, and I put in 3D, so we can see already that there are some some zones with faults. So I'll put this in 3D. So we can already see some footprints. And so the idea is to extract these fault polygons and then to build the fault planes out of these. So I just click on the fault database that I have created and I select all of them and I can put in 3D. So here you have, you can clearly see already the footprints of the faults. So you have two zones, I would say the one here below the discontinuity with very large faults, orientation south, north. And on top of that you have some smaller fault planes that you can see here on the top of the seismic. So if I just go move here and there, so of course maybe you, depending on the seismic quality, it's there is a way you can extract more or less, but you see that here you can clearly see the footprints, and in that case we might have to go locally to, of course, refine the. So if I just look at this one, I just want to demonstrate some of the features. So I go back in 3D and there are different modes. So in a fault, you can either go for full manual. That might have to do here depending on how many breaks we have in the horizons, or you can go in assisted or fully automatic. So assisted, for instance, is extremely simple. Let's say I want to just build one fault polygon. So for instance, I want to look at this one. So I just create a fault, click on assisted, and I'm gonna go there and boom, I have my fault plane. So here I can also refine the computing to refine the extrapolation. And for instance, I can maybe take a bit more polygons and remove some of the extrapolation in B or XY. So now you see I can decide which part of the polygons I want to keep. So if I remove my polygons, I go here, I'm taking my fault, I can hide the planes to see which polygons have been taken, and I can see the polygon density. So you have a confidence scale where it's red you have a lot of polygons, and where it's blue you have less polygons. So here you see basically how I've done for one of these faults. I can of course do this for another one. So let's take one of the big ones at the bottom. So the same, I go in edit, I create a fault assisted, and up I click there. So here I have another fault polygon that I've extracted, and I can of course decide to extend or to refine this area depending on my needs. So that's an example. So then let's say I want to build a fault polygon from these guys here. So I can do the same thing. I just center it a bit my seismic. I create a fault polygon. I click here, orientation, the color, for instance, and I do like this. Up, up, up. And now it will calculate the fault plane in the area. So you see that's the one I have here in pink, which is extending this way. So I can go and look at this one. I can remove my plane to see which polygon it has taken. And once again, you can see with the confidence scale where you have more or less polygons. So that's the assisted using already polygons from the extraction itself. So that's another example. Then let's say that we want to extract faults from a surface that we have. So I can just find a surface that I like. So for instance, this one. So here I have a surface, and I want to see the polygons on the surface. So the name is 121. So I'm just going to find one-to-one name surface here. So that's a polygon on the surface, and I want to display this guy too. So I'm gonna, so here you see, I see, basically I can see my fault polygons there. And say I just want to compute the faults only in this surface. So I go once again into the fault, I go in edit. I'm gonna go click here and then click there. And it's gonna take maybe 30 seconds and you will be able to compute the faults from one selected surface of your choice. So this is again, here it's assisted, and now you see you have all the fault polygons that have been extracted from this surface. And of course, since you are taking more than just the polygons on the surface, you are computing the fault polygons all along the way. So you see, this is basically the way to quickly extract faults using assisted features. And so that's an example, and the last one I'll try to show if I didn't display everything. So if I put all my polygons, I can decide that I want to run more of these polygons and to extract fully automatically. So I just have to click here, and then it will run once again. And every time I will do an increment, you will see the fault planes being built on the fly. So that's another example, and every time you see I have runs, I see my fault polygons that are being built. And then of course I can go and refine locally the extension by recomputing the fault planes just really to surround the polygons in areas of interest. So if I just take another one, for instance, I'm going to take this one or maybe a smaller one. So this one, so I can once again go and recompute locally to have something which only reaches out to the polygons in the neighborhood. So this is a quick demonstration of the new features in Seisnetics 602 for the assisted and fully automatic extraction of faults. And in another video, I will show how to basically build on the fly fault planes by manually picking fault sticks with extrapolation as you go and you pick the sticks.